Well then, if we manage to control the population, what next? The difficulty is, of course, that there is supposed to be 60 billion barrels of oil in the 600 billion barrels of oil in the ground, and we're consuming 30 billion barrels a year, 20 billion barrels a year. If you divide 600 billion by 20 billion and you keep the zeros straight, the answer is 30, which means that at the present rate of use, we've got enough oil to last us 30 years, and after that we're in trouble. There's plenty more energy, but we're geared. The Earth is geared to the use of oil, which is by all odds the cheapest and most convenient energy source we've ever had. To develop other energy sources is going to mean a capital investment, and it's going to mean a lot of maintenance and a lot of research and a lot of trouble. So what we ought to do is start going through all this trouble and all this expense and all this effort and all this emotional turmoil right now, and conserve our fossil fuels as much as we can so as to give us as much lead time as possible. And this is going to be difficult, and the only thing in its favor is that it may save civilization for those of you who think it's worth saving. For those of you who don't, you might recall that if you don't save it, we lose several billion lives the world over, of which your own may be one. And if you still don't think that's important, then you're fortunate. Nothing can happen to you that's important. Now, where are we going to get energy from? There's plenty of energy in the universe. There's plenty of available energy in the universe. It just means learning how to use it. And what we want, there are all kinds of energy. I won't bother listing them all, because you can't pick up a newspaper or a magazine without their discussing different energy sources. We'll take it as read. There are all kinds of energy sources, and we can use them all, because in some places on Earth, and at some times and for some purposes, one particular energy source may be particularly convenient. Heck, there are many times when human muscle is the most convenient energy source, although this gets hard to believe. But try reproduction without the use of human muscles, and you'll see what I mean. It doesn't work with windmills. Well, what we need, though, backing up all this, is some form of energy which is copious, safe, and eternal. By copious, I mean there's enough of the energy to supply Earth's entire needs, even if all other sources of energy were discounted. By safe, obviously, I mean that there are no side effects resulting from the use of energy which can cause harm. And eternal means, well, it sounds like it means lasting forever. But supposing we limit it and say it lasts as long as humanity does. Is it all right if it runs out when we run out as a species? Okay then. Let's take these one at a time. What's copious? There are only two forms of energy that are really copious, in the sense of always being copious. One is nuclear fusion. This is not to be confused with nuclear fission, which we have now. Nuclear fission is very useful. It works. We know it works. It keeps New England warm during the cold winters, when Ohio freezes to death because one year it's natural gas, the next year it's coal. Meanwhile, New England has no problems. It has nuclear plants which produce the electricity, and it can ship electricity to other parts of the country. You don't like nuclear plants, I don't blame you, but you use the electricity it produces. It's one of those things you demonstrate against nuclear plants, but you don't turn off the electric switches. So that I beg leave to sniff a little hypocrisy here. But, well, if you prefer to sniff that, you may. Nuclear fusion, on the other hand, has an easier source. It's heavy hydrogen, not uranium. Heavy hydrogen can be gotten out of the oceans. Not only that, it delivers 7 times as much energy, weight for weight, as nuclear fission does. It doesn't form nuclear wastes. It does involve tritium and neutrons, which we hope will produce a far lesser problem than the radioactive ash that the fission plants do. And it is available everywhere, since water is practically a universal commodity, except in some deserts where very few people live anyway. There's only one catch with nuclear fusion, which, by the way, will last for billions of years. There's only one catch, and that is we haven't got it yet. And we don't know when we'll have it. I feel we'll have it before long, but we haven't got it yet. And when we do get it, it'll take perhaps 30 years before we can build a large nuclear fusion power plant and get all the bugs out of it. And there are some people who suspect that the bugs will be sufficiently complex so that we may not be able to make use of it after all. I hope that these pessimists are confounded, but we can only wait and see. Meanwhile, we can't afford to attempt nuclear fusion alone or entirely. We must go to the other source of energy, which is copious, can support us all, safe, produces relatively little in the way of injurious side effects, and eternal, will last as long as humanity will, and that, of course, is the sun. And since this is Sunday, I say it with the proper reverence. If we can use sun power, I don't mean just in low-intensity situations as in warming houses. I mean by conversion into electricity, which is a high-intensity energy sort of thing. That can be done with present techniques. We have photoelectric cells. We have solar batteries. We can expose wafers of silicon to the sunlight and build up an electromotive force and create an electric current. We have to. It's a low efficiency thing so far and quite expensive so far. And sunlight is very dilute. There's a lot of sunlight, but it's spread out, so that we would have to coat thousands of square miles of desert area so as to get maximum sun. And even then, it wouldn't be working 12 hours out of every 24 on the average, because you don't pick up much in the way of sunlight at night. And there's so far no efficient way of storing electricity so that we can pick up a lot of electricity during the day and then use the stored electricity at night. You would have to have stations at opposite ends of the earth, different places. There'd always be some in daylight. And of course, also, even the air does stop and absorb a certain amount of solar energy, no matter how clear it is. And any time it gets misty and foggy and cloudy, it loses a lot more. And you can't help but think how much more efficient it would be if we could build these solar power collecting stations in space, put them up over the equatorial plane at a height of 22,000 plus miles, and have it revolve around the Earth in 24 hours, synchronous revolution about the Earth, so that it'll always stay more or less over one spot on Earth. It would absorb sunlight, the full range of solar energy, never in any way stopped, depleted, absorbed by anything at all, hardly ever be in the Earth's night shadow. Under ordinary conditions, it would miss the thinned shadow, the tapering night beam at a height of 22,000 plus miles, and would only pass through at a certain period of time before and after the equinoxes. And over the space of a year, it would spend only 2% of its time in the shadow. And of course, you would have a number of them all around the Earth, and they could supply the whole Earth with energy, beaming them down in the form of microwaves to be absorbed on Earth with much greater efficiency than undiluted sunlight is. Of course, we know that microwaves can be dangerous. We're not going to beam them down in the middle of Amherst, even though some of you may think it's a good idea. And there is every reason to think that we can arrange it so if anything goes wrong, the beam is instantly dispersed, becomes only minimally dangerous, and is stopped. Naturally, you wouldn't want to move through the beam, but presumably airplanes will know how to avoid it, and even if they do go through it, they will remain through it so short a time that the danger is minimal. Birds flying through it, if they decide to pause on the wing while in it and fly round and round and round, may eventually come out broiled. But I have every reason to think that birds won't do it, even if you beg them to. It may work. There's the danger of thermal pollution, that is heat is added to the earth, which it wouldn't otherwise get, so that the average temperature of the earth would go up. And that would limit the amount of energy you could receive from such solar stations, because if you raise the temperature of the earth sufficiently, why, you'll melt the ice caps and raise the water level of the oceans 200 feet and drown all the coastal plains of the world, which are precisely the most populated regions. Well, this doesn't mean we can't use any amount of heat, just not too much. It still leaves us a liberal supply until such time as we learn how to help the earth radiate the excess heat. Well, now, what else is good about this thing, which is generally considered a kind of feat of fantasy? Hard-headed people are against such solar power stations for a variety of reasons. They say, you realize how expensive it is? Sure, I realize how expensive it is. It's likely to take $100 billion a year, say over the space of $100 billion over the space of 20 years, which is say $5 billion a year. Who's going to spend $5 billion a year? It's a lot of money. It's more than tuition. Right now. But the people who are worried about $5 billion a year don't realize that we spend a lot more than that on booze, and a lot more than that on smokes. And no one has ever said that the space program does any more harm than waste money. There are rumors that tobacco and alcohol do actual harm beyond the waste of money, actual physical harm. Of course, they also bring pleasure. And people say, this is cheap of you, Asimov, since you don't smoke and don't drink, to cast aspersions upon other people's pleasures and imply that they should easily sacrifice them for something you are interested in. And I recognize the justice of this, and I sniff a certain amount of hypocrisy in myself when I talk this way.